working as a software engineer at Microsoft, and I'm also an educator at Level. So now in this video, we are going to talk about the Boyce chord normal form. So far, when we are talking about and moving in the journey of normalization, we have already talked about the first normal form, we have already talked about the second normal form, and we have talked about the third normal form. So if you've not watched those videos already, I would recommend to watch those videos first and then come over here so that you can fully understand this concept and the next part that we are starting, which is BCNF normal form, which basically stands for Boyce chord normal form. Okay, so let's quickly get started. So Boyce chord normal form, or BCNF, is basically an extension to the third normal form, right? And is also known as 3.5 normal form. Okay, so we have third normal form, okay, and we also have fourth normal form. Between that, we introduced another normal form which is known as Boyce chord normal form, also known as 3.5 normal form, because we are moving in a step-by-step process. Now let's talk about what are the rules for BCNF. Now, for a table to actually satisfy in order to be in Boyce chord normal form, it should satisfy two conditions. The first condition is that it should be in third normal form, right, which is what we talked about as well, that you need to be in the third normal form. And for any dependency from A to B, right, A should always be a super key, right? So if you do not know about super keys, I've already had a video, right, on keys specifically, a very long one where we talked about keys in great detail, right? So you can watch that video and revise quickly about what super keys are, okay? But the concept about here, BCNF, it says that for a table to be in BCNF, first it should be in third normal form, which is always the step that you have to do, right? Second, if there is a dependency from A to B, A should be a super key. So we have to ensure that A is a super key. All right. When this is satisfied, we are good to go. The second point can look a little bit tricky, right? Because we have not really dealt and worked with super keys a lot. So in simple words, we can say that if there is a dependency from A to B, A cannot be a prime attribute or A cannot be a non-prime attribute if B is a prime attribute. Okay. So here it says that if you have this, if B is a prime attribute in this dependency of A to B, then A should also be a prime attribute. Okay, that is what it really means. But let's understand the best way that we do, that is by using examples. Now here we have an enrollment table with the student ID, the subject ID and the professor, right? Which student has enrolled for which subject and which professor is teaching that subject, okay? A student with the ID 101 is basically studying or enrolled in the subject Java, right? And it is being taught by P.Java professor, okay? Now over here in this table, one student can enroll for multiple subjects, okay? Remember, here you can see the student with the ID 101 has enrolled for Java as well as for C++, which is taught by different professors, okay? Here it says that one student can enroll for multiple subjects. For example, student with the student ID 101 has opted for two subjects, Java and C++, which is possible, right? Enrollment can be done for multiple subjects. Now for each subject, a professor is assigned to that student, right? Because you are studying Java, P.Java is assigned because P.Java professor teaches Java. Similarly, 104 also opted for Java, right? And the professor P.Java is the one who teaches it. For a subject, there can be multiple teachers. Here for 102 also opted for Java, but it is being taught by a different professor, which is p.java 2. Okay. And for a subject, a professor is assigned to the student. And remember, there can be multiple professor teaching one subject like we have for Java. It's not like one subject, one teacher, right? One subject, there can be multiple teachers who are teaching that subject, and one of those teachers is assigned to the student who basically opts for that subject. Okay. Now here, what do you think is the primary key? Okay, now think for a minute. Don't look at the answer. Don't try to analyze it a little bit. How do you uniquely identify each and every row? Can I say that student ID and subject would work? If I tell you the student ID and if I tell you the subject, would that be enough? No, right? Because 101 Java and here, right? 101 Java and 101 C++. What do you think? Oh yes, it might work. Think. If I know the student ID and subject, will that work? Maybe yes, maybe no. Okay, let's take a look. So here, if we have student ID in the subject, they can actually perform and become a primary key. Okay, because student ID and subject, if we know for what student ID and for what subject he or she has opted for, it is basically always going to point towards a single row itself. So it can actually happen using a subject ID and the corresponding, using the student ID and the corresponding subject. For that, we can uniquely identify each and every row. So we know the primary key here as well. So the table was and these two together form my primary key. Okay. Now here, one more important point that you have to note here is one professor only teaches one subject, right? For a single subject Java, right, there can be multiple teachers, right? Professor 1, Professor 2, Professor 3, Professor 4. But one professor will teach only one subject, right? Professor 1, if it teaches Java, he or she cannot teach any other subject. So this is like a one-to-many relationship, correct? Over here. One professor teaches only one subject, but one subject may have two different professors. Okay. Hence, there is a dependency between the subject and the professor, where the subject actually depends on the professor name, correct? Whatever subject that is being taught is actually dependent on the professor who is teaching it. Okay. Now this satisfies the first normal form, because in this table you can see all the values are atomic, right? I could have also done it in the sense that 101, right? I could have done subjects as Java, C++, because two subjects are being taught, right, by a single student. But since we have segregated it, everything is atomic. So we can say that the first level of normal form is basically achieved. All the column names are unique and all the values stored in a particular column are of the same domain. Now the second rule is that second normal form, that there should not be any partial dependency over here. Okay. Now here we have student ID, subject and professor, right? And this table, it does not have any partial dependency as well, right? That the other attributes are not just partially dependent on one of the, I would say, primary key, right? So there is no partial dependency, hence it is in second normal form as well. The third one is that there should not be any transitive dependency, okay? And as there is no transitive dependency as well, right, we can say that the third normal form is being satisfied. But the thing is, first, second, normal, third form is normal form is satisfied. But the boys squad normal form is not satisfied over here. Okay, and how come that is? That in this table, student ID and subject, they form the primary key, right? Which means both subject and the student ID, they are prime attributes, correct? Here, remember, it's not subject ID, it's subject. Okay, so that means here we can say that student ID and subject, they will be our prime attributes, and professor, it will be our non-prime attribute. Okay, so student ID and subject forms the primary key, which means that student ID and subject both are prime attributes. But there is one more dependency, which is that professor is just dependent on the subject, correct? This is the kind of dependency that exists, that professor is dependent on subject. So professor is A and the subject is B over here. And while subject is a prime attribute, okay, professor is a non-prime attribute, right? And the rule was that if you have from A to B, and if this is a prime attribute, then this should also be a prime attribute, right? If B is a prime attribute, then A should also be a prime attribute. But here you can very well see that subject is a prime attribute and professor is a non-prime attribute, right? So in this case, we can say that although the first, second and the third normal forms are being satisfied, but this table is not in boys squad normal form, which is 3.5 normal form. Okay, now the question is, how do we satisfy this, right? How do we actually introduce boys squad normal form over here? So for that, what we will do is, we will decompose this table into two tables. Instead of storing everything in one table, a good idea is decomposition. You decompose the table into two tables, which is one is student table and the other one is the professor table. Okay, now the final structure will look something like this. The student table will just have student ID and it will just have the professor ID. That means this student with the ID 101 is being taught by the professor with the ID 1. Okay, and the professor table will basically have the professor ID, it will have the professor name, and along with that it will have the information about what subject is being taught by that particular professor. And now in this relation, we can say that the boys squad normal form is being satisfied. Okay, and that's what the overall idea is. Let's quickly revisit on what we did over here. I hope it made sense to you at some level. To quickly reiterate, right, when we say that we have in first normal form, there should be only atomic values. When we say it is in second normal form, there should be no partial dependency. When we say if it is in third normal form, it means that there should not be any transitive dependency. Now we are talking about 3.5 NF normal form. And what happens in this is, first, it should be in third normal form, and secondly, if there is a dependency from A to B, and if B is a prime attribute, then A should also be a prime attribute. Okay, that is what it really means. All right, and here you can see in this example, if I am storing subject, if I am storing subject, student ID and professor, right, here the primary key is student ID and subject, right, because both of them are going to be used to uniquely identify a row, where professor similarly becomes a non-prime attribute and these become prime attributes. Okay, and the relationship is that a subject can be taught by multiple professors, but a professor just teaches one single subject. Okay, so there is a dependency. This is what the dependent is, if you remember functional dependency, and this is what the determinant is. What subject is being taught right, is being dependent on who is teaching the subject. Okay, so that is what the dependency over here, where as we already know that subject is a prime attribute and professor is a non-prime attribute, which we just talked about is not valid. So how did we tackle this problem? We basically tackled this problem by breaking down the table into two different tables. The student table is different, the professor table is different, and we are just using the professor ID in the student table in order to basically represent the relationships. Okay, and remember here in the student table, PID is like a foreign key. Okay, because this foreign key PID is being used to reference another key which is like the primary key for that table. Okay, and that is what the overall idea is. Now I hope all of you understand this concept. I hope I was able to make it a little bit easier for you. I always try to give as many examples as we can because I feel that's the best way to learn a concept. It gives you a more holistic view, right? Just understanding theoretically, you might be able to understand what the dependency really means, but when you take an example, you actually see a real life situation. So it's easier for you to apply those concepts when you're actually, when you're actually taking a real life situation and implementing databases for that, right? So that is why it says that if you have to apply normalization, you should actually know the requirements, right? Because when you know the requirements well, it's easier for you to design databases after that. Okay. Alright then, I hope this is clear to everyone. The best way to again move ahead and learn more into this topic is by taking examples, taking some more examples, try implementing your database on your own and see if till 3.5 normal form, till boys scored normal form, are you clear or not? Okay, because if you're clear, it actually represents that all the topics and all the things that we have done is absolutely clear to you. Alright, thank you so much for attending the video.